Hey, hello, my name is Rick Crosslin, and we're here to start our Grade 3 Science Inquiry lessons. This lesson is our first one, and it's a pretty interesting one. I'm pretty excited about it. Very soon, you'll be doing this lesson. I wanted to let you know a little bit about what's going to happen. Our question today is, how does science answer questions with science methods? Now, scientists use a lot of different methods. And so the method we're going to use today is just one way that scientists answer questions. It's kind of, however the question is, that's the method that scientists use to find answers. Now, I'm going to show you a couple of little investigations or 30-minute science projects, and then you're going to do a couple of them. And the first one is, what tools do scientists use? And we're going to be using some tools. We're going to be using thermometers, and you're going to be using a meter stick. And it's going to be quite a bit of fun. So the first thing I want you to do is let's take a look. Let me share with you in your book what your book is going to look like. So let me stop sharing our lesson right here. And you're going to see, let's see here, in your books, you're going to be doing some reading, which is, how do scientists answer questions? And when you read this, you're going to learn that scientists answer questions in a lot of different ways. And they're going to, sometimes they use models. There's a lab for that. And sometimes they do different types of investigations. They might make a model of an airplane, or they might check the weather, or they might go outside. And we're going to do all of these things this year in science. In fact, one of the first things we're going to do is we're going to use a scientific method on page 18 and 19 in your science book, so you can actually start reading that if you like and getting ready for this investigation. And it starts with a question. And so here's a question: what material is best for keeping heat in water? And your hypothesis, or your best guess that you can test, see, a hypothesis is a scientific guess that you can test and collect data or numbers about. In fact, math is the language of science. So we might wrap a jar in fur, and then we might wrap another jar in newspaper, and then we may not leave one jar unwrapped. And so if we put hot water in these and what can we use to measure the temperature change? Well, we would use a thermometer. Thermometer would tell us how hot the water was when it started, and then every few minutes or so we could record and see how they change over time. In fact, you're going to test your hypothesis, you're going to collect and record your data, and you're going to keep records what you find, and then you're going to interpret your data, and then you're going to find out what you learned or state your conclusion, okay? And there's a lot more experiments you can do. So this is one that we're going to do in the next couple days to show you how scientists answer questions using science methods. Okay, let's see here. Let me stop sharing this and let's go back. Let me show you what that might look like. In fact, I have this set up right here, and your teacher may set this very same experiment up. So what you see here is I have a control cup, I have a cup wrapped in fur, I have a cup wrapped in newspaper, and I have thermometers, and I have some very hot water that we can pour into these and test. In fact, let's see what happens when I pour some of this hot water on this thermometer right here. Oh, I don't know if you noticed that, but that temperature is going up in that one. A little more hot water in there and see what happens. So when we do this experiment, we're going to learn a lot about how scientists might answer a question. And we're going to learn about variables. Should we pour the same amount of water in each one? Should we pour the water now in one cup and then wait 10 minutes and pour it in the other cup? So really what we're trying to do is what's called a fair test. And so that's an experiment that you'll be doing real soon. Another experiment that you're going to do is one that I like to call reaction time. And this one's kind of fun, actually. I'll tell you, all you're going to need is a meter stick and a partner. Now, I can't do this by myself. If I had someone to help me right here, it'd be a lot easier. But you're going to have a partner. And your partner will hold this at, say, 50. And your partner will let go. And you can't move your hand up and down. And teachers, I'll show you ways to do that. For example, using the edge of your desk. And your partner will let go. It won't tell you when to let go. It'll let go. And then you try to catch it. And when you catch it, you see where your finger was. Mine was at 50. And then it went to 60. 50, your partner will let go. Oh, that time it was 62. Every time you do that, that's called a trial. And so you might do something like write down. Let me switch cameras here and show you what I mean. You might do something like, switch cameras. I have a little note. I'm going to write it down. Here we go. So you might do something like this. Reaction time. Trial 1, I started at 50. That was my start. My drop, it went to 61. My reaction time, I subtract those, would be 11 units. 11 units, okay? So see how I did that? I started at 50. My partner dropped it. It was at 61. So I subtract these two. So my reaction time is 11 units. Now, scientists don't do things just once. And so you're going to do this experiment, and you're going to do it 10 times. And that will collect a lot of data. As a matter of fact, let me show you the worksheet that you'll be using for this one. Here it is right here. Explore it. Hold your stick out. It shows you how to do it. And there's even, I ran off a reaction time bar graph. Here are your trials down here at the bottom. And your different units of time in centimeters on the side here. So that's going to be pretty interesting and kind of fun to do. So those are two different, let me change cameras here. Those are two different 30-minute investigations you can do. We'll probably do the water one first. That'll give it some time. Then we'll do the reaction one. But you see, scientists, they do all kinds of experiments. And here's another one that your teacher knows about. It has to do with drops on a penny. Drops on a penny. So this is one. Let me show you how this one is set up. What I have here, and let me just switch cameras real quick. I have some pennies. Okay. And I have some pipettes. And so let's see if I just take this guy right here and lay this down right about here. Here we go. And I put a penny right here. Maybe put two brand new pennies. One, talk about variables. If you're going to do this, it would be important to do it on the heads each time. And so I have another tool scientists use called a pipette. I make a prediction. I wonder how many drops of water, 1, 2, 3, 4, I could get on that penny. So you could make a prediction. You could predict, and then you could test your prediction. I'm going to say 25. Here we go before it spills out. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Well, I'm going to stop there for a second. I'm going to change cameras so you can see the side view of this to see what's happening. See, in science, sometimes when you do an investigation, you're not sure what's going to happen until it already happens. Look at that. That's kind of cool. I've got 20 on there. Let's see if my prediction was 25. 21. 22. Uh-oh, I'm spilling it. I got to 22. So a scientist would probably do this several times. So let me dry this off. And I might change my investigation. So I got 22 on regular water. But what would happen if let me switch cameras here for a second. What would happen if I changed a variable? What happens if I decided, you know what, I think I am going to add some soap to the water. So here I am, I'm going to take the same water, I'm going to add a squirt of soap. Got some soap in there now, big time soap. Take a look at it right here. And I'm wondering if soapy water will be different if I'll get the same amount of pennies. So this might be my question. Does soap affect how many pennies, does soap affect how many drops of water, soapy water I can put on a penny? What do you think? Is it going to be more, less, or the same? See, in science, you make a prediction, you make a hypothesis, and then you test your hypothesis. So here we go. Let's see how many I can get. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You know what? I'm leaking already. I think I started leaking at 12. Wow, that's kind of interesting. So that tells me that soap has an effect on the amount of bubbles or water drops I can get on a penny. Now, those are just 3 quick experiments, projects that use science methods to answer a question. And you're going to do 2 of those. And teachers, if you may want to do that 3rd one, that's fine with me. The really cool thing about this project is there's other lessons you're going to do during the week. And then finally, at the end of the day on Thursday, your teacher knows about sharing with all of us, all 45, 46 3rd grade classes, what you learned. And there's a place to do that. And your teachers will know. And actually, what you do is you have on our Google Documents, there is a slide set that says, if I can focus this here we go. How do scientists answer questions with science method? You're going to insert your observations, your findings, your conclusions, images, or even more questions you have about this lesson. So teachers, when you do this, make sure you put your student's first name or just your name, the school, what grade, and what you found out. We're going to add to this document, and then come Friday, I'm going to be at a different school. I'm going to be at a different school every week. But on Friday, I'm going to come back on this video and share and see what you learned at the different schools. Remember, science is for everyone. And if you're like me, you love science. I can't wait to see how you use science methods to answer a question. See you soon.